We have one more thing to do before we can get serious about making the tenons on the end of our bars for our window grill. And this is another useful tool that you'll need lots in the shop, even if you're not making this project. It's not specific to this project. It's a very generic tool, and that is a monkey tool. And what a monkey tool does is it allows you to slide the monkey tool, just a bar with a hole in it, over your tenon and upset this shoulder a little bit and refine it and make sure it's square. It will match whatever the end of your monkey tool looks like. So if your monkey tool is good and square, that's what you'll end up with. Now, I like to put a round hole in the edge of my monkey tool so that I can see if that tenon is too long. If you drive that tenon all the way into the monkey tool, you're just going to upset it, and that's a bad thing. And you can make monkey tools in whatever size you want. I've got quarter, 3/8, half, 3/16. There's lots of different options, whatever size tenons you're making. These also come in handy for making sure parts are tight together when you do riveting, and we'll cover that more in a video about just riveting. But there are several ways to make monkey tools. Probably the best monkey tool, the easiest solution, is to just go ahead and machine these either on a lathe or a drill press. But since not everybody has that, I've got one here that was done at the anvil, and you can see it's a little bit different. I don't think it's as good a solution, but I think it's a completely workable solution. So we're going to make one of these, and I'm going to show you real quickly some of what I do to make the other monkey tools. Certainly a lathe is the #1 choice for making monkey tools. It's going to make a perfectly centered hole that's perfectly straight. You can face off the end of the tool and make sure it's a perfect square, and you will end up with a much better tool this way. But not everybody has a lathe, so this is not the only option. I'll just present it here. And if you own a lathe, you probably already know more about it than I do. I am not a machinist. I'm a blacksmith. Now, I talked about that cross hole. I drill that first at the drill press, and that gives me a sight to know when I've drilled deep enough with the drill bit. Actually see that drill bit has gone into that hole now. I've already drilled this one, so it's just a quick touch up here. So by having that cross hole in there, I know when I've drilled all the way through, and that'll make this a much easier monkey tool to use. This particular one is for a 1/4 inch bar. And again, the same thing holds true in the drill press. I've pre-drilled the little side hole. And we've started this one too, just because it's going to be quicker to sort of see what's going on here. You really don't need to watch me running a drill press or a lathe. This is a blacksmithing channel. I just wanted to show you that this can be done this way, and if you have this equipment, you'll end up with a better tool in the long run. But you can feel that break through, and you can see some chips come out, so you know you're all the way through. Now the only real problem with a drill press is getting this centered. So if you can get a good center mark on there, but then again it doesn't have to be. This isn't a tool that rotates in use, it's a tool that is stationary. So if it's not perfectly centered, it's not critical. The whole square with the end is the critical feature. And this is a 3/16 monkey tool. So we are going to start with a piece of 3/4 inch mild steel. The two I just showed you being machined in the lathe and in the drill press are actually S7, and that is what I would prefer, either S7 or 4140 for making a monkey tool. It's good steel, it's made to resist that kind of abuse, it will last a lifetime. a tool made out of mild steel, and you can do the machine version this way. I know a lot of people who never make a monkey tool out of anything but mild steel will last a few hundred uses, but it won't be a lifetime tool. So it just depends on how much you're going to do it. I'd certainly make your first ones out of mild steel and not waste your time with the tool steel until you're sure you know you're making a tool you like. This is a 5.5 inch piece of 3/4 inch square. We'll put that in the fire. And I'm going to use 3 tools besides your forge, hammer, and anvil. And one of them is the same round punch we've been using for everything else. This punched the holes in the rails for the grill project. It punched the hole for the tenoning die that we did in the last video. It's going to punch the hole for the monkey tool. It's a good versatile punch, and this is one we made in an earlier video. And I'm going to use a 3/8 drift pin. Now, I've been using this pin in a lot of these same videos. It goes right along with the punch for refining the hole to a perfect 3/8 round. This is, again, just a piece of S7 drill rod. You buy it as a 3/8 piece and taper both ends so it drives all the way through. Piece of cake to make one of these. For 3/8, you can make it out of mild steel. You'll bend it, you'll have to straighten it, you'll fuss with it, but it'll last quite a while out of mild steel, and you just make more of them. They're pretty easy. I've made hundreds of hinges with this 1/3/8 pin, and it's still going strong. It needs to be dressed every now and then, but that's about it. So there's an advantage to using tool steel. The other tool, and one we haven't done much with, is a simple hand fuller. And that's because this tool needs a groove to provide the clearance for the round bar to come up through when you're doing the monkeying of the tenon. So your tenon needs some place to go. So we need to put a groove in here, and for that we're going to use a simple hand fuller. You can use a regular top fuller that is struck with a sledgehammer if you have a striker. The first thing I want to do is offset where my bend will be in this. It's easier to bend the skinny section. Plus you need a skinny section for your groove to go into. And I want to take this about half, so about a 3/8 thickness or just slightly more. So that's pretty good. And when we bend this, we'll actually bend it this way, and that helps form a better corner. If you bend it this way, you form a cold shut in there. But the next thing, we'll punch the hole. This gives us the chance to punch a hole flat, where it's nice and easy to work from both sides, easy to drift it. And we'll get a much better, more accurate hole that way. And now we're just going to punch a hole center on this, just like any other punched hole. It's just a little bit thicker material. But it also stays hot longer because it's thicker. If you're worried about your punch sticking, a little coal dust in there doesn't hurt. I got my little target mark I can see on the back. There's our slug. Now, is that even close to the 3/8 that we want? Very close. So I think we're ready to drift that the next heat. So it's just a matter of driving the drift through. And that'll leave us with a nearly perfect 3/8 hole. If this cools, it'll actually be a little undersized. So at that point, we're going to need to run a drill bit through there ideally, or deal with an undersized tenon. The next thing we need to do with this is fuller or groove in here. And that's actually folded on the back side. So we'll fuller our groove, and then we'll bend this over. To avoid chasing this around the anvil, we might want to use a hold fast here. Part of the problem is this is going to be kind of up in the air where we need to do the groove, so that may not work as well as I would like, but let's find out. I think that'll be just fine. It's starting our bend for us. Because that's tapered, it'll actually need to be a deeper groove up in the thick spot, so you get down to about the halfway point on this 3/4 square bar. So it'll take a few heats. Take a moment to straighten this between heats so that it's straight when you're done instead of being all crooked and then having to straighten a big problem. I think that looks plenty deep enough to me. I'm pretty happy with that. So next thing, let's bend this over and try and create a fairly nice corner. Not that it's super critical. So I'm going to go ahead and cool this in so I don't mess our hole up any more than I have to. And because this is mild steel, that's quite easy to get away with. I want a nice 90-degree corner with a dog leg, if that makes any sense. That's pretty much the tool right there. The ideal is that the hole is centered on the shaft so that when you're driving the monkey tool, your impact is even all the way around. Otherwise it tends to get off and leave you a crooked shoulder. Again, I've cooled off the part with our hole in it. And I'm really just refining this to make it a prettier tool at this point. Now let's see what we think about the whole thing here and drive that drift back through there and see if it's going to fit the way we envision it. So that goes pretty much right up our slot there, which is what we wanted. A little straightening. I think that's going to work just fine. Now the problem is getting the drift back out in this situation. It kind of gets wedged. That was some gentle hammering here. It's all doable. Now it certainly ends up with just a little bit of a propensity for a cold shut right there, but I think for a mild steel tool that isn't so likely to crack and one we aren't going to use for the rest of our lives, it will hold up. So that is pretty much the finished tool. We're going to let that cool now. The very last thing I want to do with this is just run a 3/8 drill bit through it, which is pretty grabby because it's an imperfect hole at this stage, but it's doable. And that also helps guarantee that your slot is going to line up and be the right size. Well, here we have a finished monkey tool that fits over our tenon and has just enough clearance for an appropriate tenon. This tenon is probably a hair long on this particular bar. And we will use this tool when we make the tenons for our project, for our pickets. We need to make 10 of them. And we'll see how this tool holds up. This was fast enough and easy enough to do, and probably has 25 cents worth of material in it. And for me, this came out of the scrap bin. It wasn't anything that I was going to use for another project, so for that matter, it might as well be free material, because otherwise it goes to the recycler. So it's a reasonable way to make a tool. I don't think this is a permanent tool. I think this joint may be a little weak and it may break eventually, but it should get us through this project. Monkey tools made out of tool steel are certainly better, but even a monkey tool out of mild steel with a hole drilled in it is going to be a better tool in the long run than I think this is. Now, I think you can make square monkey tools. I've heard of people doing it. I've never tried it for square and rectangular stock. At some point we'll have to do that. I don't know that you can take a piece of bar like this and punch it endwise to make a monkey tool like this just using a punch. I think your punch is going to get stuck, it's going to overheat, it's going to upset in there. It's just going to be a mess, in my opinion, so I've never tried it. Doesn't mean it can't be done, but I've never made that effort. I think there's probably another way you could make this kind of a monkey tool, perhaps in two halves, weld it together, or wrap a tube up like they used to do rifle barrels. But even that required machining, so you'd still have to be able to bore that out to make it an exact size, but it might be possible. Now, as far as materials go, these are all made out of jackhammer bits. They're just ideal material for it. You get jackhammer bits in different sizes, and they make good monkey tools in different sizes. This big 1/2 inch one is 1.25 inch hexagon, a jackhammer bit. These were made out of new S7 round rod. You can make them out of square. If you're using mild steel, square might be easier. Might be easier to clamp up under your drill press anyways. You'd have to have a 4-jaw chuck in the lathe though. So those are some options. This is an option if you have air in an air hammer or an air chisel. Roy over at Christ-Centered Ironworks, I think, just did something on this. This is one I made ages and ages ago. I don't use it very often because I never do production runs of tenons that I need a monkey tool on an air hammer for so long that it's worth getting it out of the drawer. But if you're doing a bunch, it's an option. I'd encourage you to go watch his video on air hammers and how to use these. This is probably the cheap one that he says he doesn't like because he just got a new one that he does like. But in any case, now one other option for a monkey tool, and that is what they call hollow core drill rod. I knew I had a piece around here somewhere. This is a drill for drilling in stone, and it's about 5 feet long. It's octagonal, and it has a hole all the way down the middle of it. You probably can't see that, but and this one I can see daylight all the way down there. So this is almost a 5/16 hole. It's not big enough for this project, but if you have a drill, this would be easier to drill out. Cut it to length, anneal it first, and then drill it out. Now, think about what this is, though. This is your safety warning, and do this at your own risk. If you remember that old song about John Henry, the steel driving man, who got put out of work by a steam drill. Well, this is what the steam drill was running. The jackleg or the steam drill runs these big bits, and they are drilling hole in rock, in tunnels, and construction for roadways. And what are they doing with those holes? Well, they're putting dynamite in them. And there are stories, and I've never heard of anybody firsthand again, so it might just be a blacksmithing fable, but there are stories that the miners used to use these for packing the dynamite in the holes, which means there's a certain amount of TNT packed into some of these old hollow core drill rods, and if you put it in the forge, you're liable to blow yourself up. That may be true, it may not. Do it at your own risk. Now, for my money, I would be pretty satisfied because I can see all the way through this bar, but if you take a round rod that just fits and run it through there, I think you'd probably be okay. I'm not too worried about it, but if you're at all worried about it, and if you can't see all the way through there, perhaps you shouldn't be throwing that piece in the forge. I'd hate for somebody to blow up a hollow core drill rod. But it's a ready-made monkey tool. A lot of people use these. I think they might be available with different size rods, different size holes. I have no idea where you find these normally. This one came from an antique store, so I scrounged it up real quick. And there's enough in there for a whole lot of various monkey tools. It's not very good for anything else because it's got a hole in it, so it's not good punch or chisel material. It's really only good for monkey tools and other hollow tools, some riveting tools maybe. Hard to say. Anyways, that's it for monkey tools. Make them out of good steel, they'll last forever. Mild steel ones may last your whole career, just depends on how often you need them. I'd make the first ones out of mild steel. In this version, I'd certainly make out of mild steel. I don't think it's worth the time and trouble to make that simple a tool out of tool steel because I don't think it's going to last either way. I think eventually that's going to crack right there. So I hope you enjoyed the video and give it a thumbs up. I'd love it if you'd hit that subscribe button. Please share the videos with your friends. Watch more of the videos. But then get out to your shop, make something, stay safe, don't blow yourself up. Do wear your safety glasses, and we'll see you for the next one.